Hey guys, welcome to my channel. I'm LeetCoder. Today we have an amazing problem for you guys, a very good problem. So let's quickly go ahead and read the problem statement, guys. So it says to find root of N-Ary tree, right? So it says we're given all of the nodes of an N-Ary tree, right? As an array of nodes objects, okay, where each node has a unique value, right? So it says return the root of the N-Ary tree. Return the root of the N-Ary tree, okay. It says an N-Ary tree can be serialized as represented in its level order traversal for each group. Okay. It says, for example, the above tree serialized as one null. Okay, interesting. It says the testing will be done in the following way. The input data should be provided as a serialized subdivision of the tree. The driver code will construct the tree from the serialized input and put each object into an array in arbitrary order, right? So interesting. Okay, so the driver code will pass the array to find a root, and your function should find and return the root node object, right, in the array. So the driver code will take the return node object and serialize it. If the serialized value and the input are the same, the test passes, right? So it's very interesting, guys, right? So our job, right, is to kind of find the root, right? So we'll be given a list of nodes, right? And our job is to kind of, the algorithm that we're going to write is to find the root node of the N-Ary tree, right? So based on the arbitrary nodes that we're given, right? And then all the nodes have those kind of things, right? That's the definition of a node, right? They have the children, they have a value, right? And things like that, right? So we're given, like you see, we're given a bunch of nodes, guys, right? Interesting. So, and they're in arbitrary order, right? So, yeah. So but looking at it visually, it's easier. I could just say one is the root node, right? I'm saying, but the nodes will be given to us in a arbitrary order, right? So it could be, we're given 6, 2, 1, 3, 5, 1, right? We're just giving a list of nodes, right? You know what I'm saying? And we need to write the logic to kind of somehow return the root node, right? Which is 1, right? Okay. Like they said the example, right? So the array could be passed in at 5, 4, 3, 6, right? Or it could be 2, 6. It's just random shuffled, right? In a messed up way so that we have to write some code, guys, right? And now this one's the same, guys, right? You know, we're given the nodes in arbitrary order, right? And then we need to return the root node, which is one node, right? Return the root node of the tree, right? So how can we solve it, guys, right? By giving to us a bunch of nodes in arbitrary order, how can we find the root node, guys, right? That's the kind of logic that we need. Okay, we could see that. Okay, we see nodes. Okay, what makes the root node different, and why do they need the root node, right? Okay, the root node is what makes it different than all the other nodes, right? What characteristics does it have that can allow me to detect, okay, this is obviously the root node, right? Okay. We know that we can't visit, right? Like we can't go up, right? So that's kind of can know the root node. I was gonna say keep going up until we find a node that doesn't have a parent, right? That's how we'll know that this is a root node, right? So the root node doesn't have a parent. Okay, that's something that one of the characteristics that's important, right? What else? Okay, so we can't go up. What else can we do? We can. What we could do, we could visit all of the, so we're given the list of node as object, right? So for every node, right, we're gonna visit our children, right? For each child that we visit, guys, we can have a way to mark it, guys, right? So the original thought, what we could do, so for each of the nodes, right? So all the other nodes will have could have some kind of a n degree, right? And only the root node would not have an n degree, right? So that's kind of the process, right? So what we could do, we loop through all of the nodes and we visit the children nodes, right? We put it in some kind of a, we mark it, right? So we could put in some kind of a set, guys, right? To say, oh, this node has been visited, right? So this node has been visited, so we mark it. So now as we're visiting all of, so for every node, right, we visit their children, right? And we mark the children, we put in some kind of a set, right? So we put in a set, we could loop through it again, right? And the node that doesn't have a, that's not part of the set, right? Which means that there was no parent that visited that node, right? This lets us know that this node has no parent, which means that this is the characteristic that we're looking for, right? That this node must be the root node, guys, right? This is the most the important part about it, right? So this is the root node, and this is how we're gonna return it, guys, right? So it's kind of the logic and thought process. So let's say we're given 5 first, right? We visit 5. 5 has no children. Nothing gets added to the set. We say we visit 3. 3 visit its children, right? Visits 5, puts 5s in the set to mark it as visited, right? Because it's with children. That means there's at least one parent, right? And then it does the same thing to 6, right? And then 2 has no children. 4 has no children, right? And then 1 adds 3, 2, and 4 to the set because 1 is the root node, is the parent node for all of them, right? And then after we're done, we just loop through all of the nodes in the set. We see that 1 is not in the set. Then we say, all right, cool, this must be the root node, guys, right? Hopefully you're able to follow that process. Let's quickly go ahead with the implementation, okay? So what we're gonna have, right? Make sure I zoomed in fine, right? So this is exactly what we're gonna do, guys. So what we're gonna do, let's go ahead with implementation, okay? We're gonna have, guys, right? We said that we agreed on a set, right? Let's do a set of nodes. Let's call it sets. We need new assets, right? And then we're gonna loop through, guys, right? We're gonna loop through our list, right? So node and the tree, right? And for every node, guys, right, we say that we're gonna visit our children, right? Because we have access to our children, right? It's part of, we have reference to them, right? Because that's how they're stored, right? We have reference to our children, so that's what makes it extremely convenient, right? So we do node that children, right? And then we do sets that add that child into the set for me, right? And yeah, there's not much to it, right? And then after that, what we're gonna do another loop, right? To pretty much check all of the nodes, right? All of the nodes in the so we loop through all the nodes in the tree, right? And then we see if the set, right, does not contain that node, right? So what we're gonna do, we're gonna say we initialize a root node, right? We put it as null, right? And if, guys, if the set does not contain that node, right, then we can safely say, guys, right, that this node must be the root. And then we can automatically break to avoid wasting time because we've already found our root, right? And after we do that, guys, right, we return the root node to the caller, right? So let's just go ahead. So we got a set of nodes, right? Pretty much it's the set to keep track of all of the child node, like, you know what I'm saying? So because we're visiting all the nodes in the list, right? And for every node, we're visiting all the children, right? So we mark all of the nodes that are children to a some node, right? If they're like a child to a node, right? That means they cannot be the root, right? Because the root, the characteristic that it has, right? It has no n degree, which means there's no parent, there's no node pointing to it, right? So which is just, that's the important part, right? And then we do a node root slash to null, and then we loop through all the nodes in the tree, and we see if that's in the set. Then we do this check run code. Okay, we seem like we've had this small test case. Let's press submit, see if we pass all the test cases. Awesome, guys. We're able to pass all the test cases, guys. So I want to thank you guys for taking the time, guys, to kind of watch a video, guys. If you guys found value, make sure to give me a like. It really does help out the channel. It really helps out a lot of small channel like mine to get some exposure. I want to say thank you guys for watching, and I'll see you guys in the next video.